Hey everybody, welcome back to another week with Patovi. My name is Alexis Abril. I'm one of the senior developers at Patovi, and with me is the core lead for CanJS and one of the authors of some of the testing tools you're going to see here in a little bit, David Luke.
Hey.
So we'll be talking about general testing approaches and how we test our apps at Patovi, what we kind of talk about. Some of this is, I said approaches because some of this is more opinion, but hopefully we can help you get to where you're going with your applications. If you have questions at all throughout this series, if you're joining us live, feel free to ask us in the Q&A of the Hangout. We'll see those here. Or if you are on Gator, we are at Patovi/JS-training in Gator. So you can ask questions there. But without further ado, let's get started here. Without further gilding of the lily. So when it comes to testing, there's a few specific things we want to talk about. But before we get into that, I want to define a few terms only for purposes of this podcast. You're going to hear these terms in a lot of different software shops, meaning a lot of different things. I don't believe there's any formal definition for any one of these terms. So roll with us for a little bit. When you hear functional testing, we're going to be talking about testing from the perspective of the user. In other words, a scenario where the user clicks on something and some other action occurs. I click on a button, the background turns red. This is what you call a functional test. It's not so much about what's happening behind the scenes as it is what is happening from the user's perspective. When we're talking about unit testing, we're talking about what is happening in memory, what is happening behind the scenes. This is testing from the perspective of the developer. So things like, hey, if I change the first name property on a user model or object, then the full name property of the object should also change. This is testing from the memory's perspective. So what is going on behind the scenes? Integration testing is just testing interactions between two or more modules. This could be at any level. If you're just talking about two objects interacting with each other or two classes interacting with each other, this is all you need to be considered an integration test. Another example of an integration test is you have a full end-to-end, I click a button, a record gets added in the database. That's also an integration test. It's any set of tests that are combining two or more modules. The more integrations you have, be careful, the more brittle your tests are going to be. You're adding a lot of moving parts between clicking a button and a record being added in a database. If that test fails, what does that mean? It doesn't mean too much, really. It could have been an error in a stored procedure that got updated. The database could be down. The internet connection between your client and your server could be down. There could be an error in your JavaScript. There's a lot of moving pieces in that. So when you hear, actually, there's one more definition I should have added to the slides, is smoke testing. If you're talking about end-to-end testing, that should be a really, really small set of tests. We refer to those as smoke tests. Something that really doesn't tell you what's broken. It's just a signal that says something is wrong at a high level in this application. So those are some of the terms that you'll hear me and David use through this podcast. Let me make sure I'm still broadcasting. Yeah, I'm good. Okay. When we're talking about tools that you can do some of this in, so functional testing, again, from perspective of the user. So something that can script, clicking around a page and observing and asserting changes that have happened on the page itself. There's FunkUnit, Cucumber, Selenium, and Casper.js. All do, there's some overlap between the tools. Some of them do more, some of them do less in terms of approaches, but they're all generally doing the same thing from the user's perspective. Can I click around the page? Selenium is probably, it's definitely the oldest out of this bunch, where you can have a macro generator that records you clicking around a page and scripts what is happening. Cucumber had a really cool concept with this BDD syntax where you could generate your own like internal syntaxes. So you could write normal English to describe your business scenarios that would translate into a test behind the scenes. FunkUnit is something we'll be demoing today. It's been around since 2009, 2010. I'm not sure. It's been around for a few years. But this is something that takes the ease of a jQuery selector syntax. So if you like setting $div, then FunkUnit's pretty cool. It's just going to say f div, and then you can invoke actions and wait for things to happen in the DOM. You'll see a demo of that shortly. On the unit testing front, when you're specifically looking about things being changed in an object, properties on a model, you have the three big dogs are QUnit, Jasmine, and Mocha. Jasmine is from Pivotal Labs, I believe. QUnit is from the jQuery team, and it's the jQuery Foundations framework. And Mocha, which is relatively new, I want to say around 2-3 years, maybe a little bit longer, but a really, really cool and powerful framework. These are not all the tools. What's that?
Started as a Node framework. You can also run it on the server.
Oh, nice. Yeah.
It's nice to like write tests the same way, both on the server and the client. I always think there is not that much of a difference between all of those anymore. There was a lot of philosophical debates, but I think right now they converge to the point where they all pretty much do the same thing.
They're all really, really similar. What I do like about Mocha is the separation between the assertion libraries and the test writing. If you don't know what I just said, don't worry. We'll show you here shortly. So I'm going to break this. We have some code examples. I have a sample application to show you guys when talking about writing your tests or creating this test harness. Excuse me. I'm going to break it down into two basic categories: the writing of a test and the running of a test. That sounds simple, like a no-brainer almost, but when it comes to choosing tools, it's very confusing sometimes. I hear this a lot. David, I'm sure you hear this a lot too in your experience with different teams is, hey, how do I get QUnit to run in a Java environment? Or will QUnit work with FunkUnit? I don't want to use FunkUnit because it'll get rid of all my Jasmine tests. And these are none of those phrases I just said really coalesce into an actual problem. Those are all just misunderstandings of what each tool is meant to be used for. So we'll talk about the different ways you can run a test and different ways you can write a test. So let's talk about unit testing first. I have a really, really simple application here. This is just a list. It's a simple grid. We got some hobbies, basketball, football, and chess listed over here. And we have some votes for each hobby, maybe how popular the hobby is. And you have some up and down arrows. So I'm going to click up on basketball. You see the votes increase to 11, then to 12. Now if I click down, it's going to go all the way back down to 9, however many times I click it. So a very, very simple application. Let me show you the code running that application. I'm using CanJS for purposes of this, but this could be written in anything. But I have a simple array of our objects we're showing in the list. It's just votes and a number and the name and a string. And I'm throwing that into a can component. Now a component is comprised of two main parts. The template, this is the table that's listing all of this data. It's rendering it into a document fragment or being composed into a document fragment later. And our view model, this is the logic behind the scenes. So when you click upvote, it's going to trigger this function. It's going to invoke this function. And this function is just going to take the current attribute of votes and increment it by 1. If you click downvote, it's going to do the inverse. So you have two basic layers, if you think. You have a section of business logic I'm going to refer to this as a business logic piece, where this is changing properties on an object based on the invocation of some method or setting some other property. In this case, it's invoking a method. But there's no DOM interactions here. You'll notice nowhere in this, CanMap is just an object. It's an observable object for those unfamiliar with this. So we're just creating an object with two functions. That's all this is. We're not modifying any DOM. There's no $li first.html is now going to be this new votes. We're just incrementing the property. And then we have our presentation layer concerns. We have something in the template that says, hey, I want a new TR for every hobbies. Every hobby in my array, I want to produce a new table row. So you have presentation layer and business layer concerns. For unit tests, I'm going to focus on only the business layer concerns. I want to make sure this function increments my hobby votes, and this function, downvote, decrements my hobby votes. So for this example, I'm going to use QUnit, because that's what I can live code really quickly. So here is a really simple test harness for QUnit. You can write this a few different ways. You can write this even simpler. I'm assuming this is the simplest version for those using a module loader. I'm assuming most people watching this podcast, if you've been following along, you're probably working in some kind of UI related position, which means you're at a corporation that's building some relatively non-trivial application, internal or consumer facing, but it's something where you're going to have many JavaScript files and probably more often than not some type of module loader, Steel.js, Require.js, Browserify, etc., using something to organize your code. If you're doing that, most of the libraries, QUnit, well, I shouldn't say most of the libraries, but QUnit likes to run immediately. So it doesn't know that you have a module loader behind the scenes loading files and dependencies asynchronously. It's just going to say, let me run the tests right away. So in our case, what we're going to do, this whole top section, I'm going to break this down, is just QUnit's boilerplate markup. This is just what you need to render a QUnit results set. We're going to load QUnit itself, and then we're going to tell QUnit, this is QUnit config auto start false. What this is going to do is tell QUnit, hey, chill. Just don't start the tests yet. I'm going to do something, and then I'm going to tell you when to start again. That's all this is doing. Then we are going to load Steel, which is our module loader. Main empty. I'm just telling Steel, don't do anything. And then I'm going to load our test file. And what this is doing is saying, hey, load tests unit.js, and then when you're done, kick off QUnit.start. So all in all, this page is loading QUnit, telling it to chill, loading Steel, and then loading our tests. Once the tests are loaded, we kick off QUnit. A QUnit test, really simple. If you're just getting started in JavaScript testing, I highly recommend it. It's just a really low bar and a really powerful framework to get into. What I'm loading is any dependencies I need to run my tests. So in my case, the big dependency is the view model that we were just talking about, this file that had upvotes and downvotes. What I'm going to do is have two tests, one for upvote and one for downvote. In my upvote, I'm going to create a new instance of this view model. I'm going to give it some arbitrary hobby with votes 0. I'm going to upvote that hobby, and then I should see I'm going to have an assertion. Equal is an assertion provided by QUnit that says, this is what I have, this is what I expect, votes should be incremented. So we started with vote 0, I upvote hobby, votes should be 1. Pretty straightforward. The reason we did all of this markup, and then wrote the tests in these ways, is so that we can run the tests like this. Like a tech. Let's see here, tests, unit.html. we go.
I'm confused about your download test.
About my download test? Oh, let me go back. Oh, I just copied and pasted.
Okay, so we're going to change that.
Let's check out. Yeah, this is what happens when you write demos in the middle of the night. Decrement. Actually, I could leave this as 1 and change this back to 0. And we should see, I'm going to show you an example of a breaking test. Oops. There we go. So this is the QUnit reporter in a browser. So we had that HTML page with its boilerplate markup so that we can run that page in a browser. All you have to do is open in a browser. I'm using it from a local server that I've set up, but you can run QUnit tests generally from the file system as well. I don't recommend it. Typically in your applications, you're making AJAX requests and so on and so forth, which is really tricky when you start doing things like that from the file system, especially if you have a module loader. Browsers generally don't like that. So here we have an example of a QUnit test run. You can see our simple viewModel upvote has 1 assertion, and this passed. So it's a nice blue with a little green indicator for each assertion. And we have a breaking test here. Simple viewModel downvote is currently failing. We expected 1, we got -1. So if we take a look at our test, we can see, hey, votes is currently 0. We downvoted it. 0 minus 1 is -1. So our assertion here is incorrect. That should be -1. Or I could change this to 1, so on and so forth. This is just an indicator of a breaking test. Here we go. Both tests are passing. It's probably a bad way to do this. Let me break this test from the viewModel itself. So we had some feature come along. We've modified the viewModel. We said, hey, here's the new function. Go and run the tests and realize, oh, we're not meeting the API that we've agreed to. So if you hear the term test-driven development, which I'm sure is pretty common these days, you're talking about writing your tests before, or as close as you can before, the actual code gets written. So if you look, this is a really simple function. We're just changing the votes to either +1 or -1, what they currently are. But maybe these functions were really, really complex. I don't know how they would be, but let's pretend they're a really, really complex function. If it's that scenario, you would want this test written prior, perhaps. You want to say, hey, I don't know how I'm going to implement this function, but when I call it, this should be true. So this is a really nice approach to guarantee you have test coverage prior to the actual release. A lot of times in rich application development, we get really, really caught up in the business needs, maybe more so than we need to. Excuse me. We need to deliver this feature as fast as possible, and that's all that matters. So tests and documentation typically fall to the wayside. If you followed the Bitobi blog, Brian Michelle had a really great article on the success and failures of projects at Bitobi. We chronicled the last 10 years of development at Bitobi, and we said, hey, which projects succeeded, which ones failed, and why did they fail? And one of the largest factors in terms of development needs on a project was for failure. One of the biggest indicators was lack of testing and lack of documentation. So you don't want to let that fall by the wayside. The next time you have a giant feature, let's say this was a big function, you got it working on day 1, the release is great. 6 months from now, there's another feature that modifies that same function. Well, if you didn't have tests, if we didn't have these tests written, then we would never know if we're actually breaking things. So one approach to it, I'm a big fan, write as many tests as possible. Now this is at the unit level. I keep going back between unit and functional in these terms. You can use QUnit to do what I'm about to show you, but this is basically what we're talking about when we're talking about unit tests. Does that make sense? Everyone's still good? Cool. All right. Let's talk a little bit about functional tests. I'm going to open up a different browser because I'm going to have a lot of pop-ups here in a second. Okay. I hope it's going to open up. Little spinner. Spinners be spinning. Okay, so we have our simple application. Over here, a functional test is from the user's perspective. Now, this is really, really useful in two scenarios, or more than two, but two big scenarios that I care about. One, are you meeting the business needs? I can write a really efficient function and attach it to some object, but that doesn't mean I'm meeting what the designer has had proved or what the managers in the business are requiring. So, and I know this has happened to me before, David. I don't know if it's happened to you. I'm sure it must have, where you've spent days or weeks building some type of module behind the scenes, and you finally merge it into some kind of feature, and nothing works. And you're so sure it's going to work, too. You're like, why didn't this work? It's probably because something from the user's perspective isn't taken into account. This is where you use things like FunkUnit or Selenium or any of these other tools. What this is doing is this is going to script clicking on this button and asserting some text on the page is being modified. It has no idea what's happening behind the scenes of your application. Whether you use CanJS or Ember or Angular, it has no concept of it. It just cares, I'm going to open this page, I'm going to click this button, and this text should be some other text. That's what this test is doing. Let me show you. I'll run that test again really slow. Let me show you what that's doing. So earlier, we said we had these presentation layer concerns. This is how we're testing it. So here's our markup. You'll notice it's the same as the QUnit markup. We're using QUnit style sheets, and we're using QUnit auto start false, QUnit.start. The only thing we changed was the title, which is arbitrary, and we're loading a different test file. FunkUnit.
You could technically run them in the same file, really, too, right?
You totally could. You totally could. That's a great point. I separated them only for just, I like putting things in buckets. FunkUnit is not meant to, or functional testing libraries in general, are not meant to compete with your unit testing approaches. It's not FunkUnit versus QUnit or FunkUnit versus Jasmine. They're meant to work in tandem. They're meant to work together. So what FunkUnit does, let me bring up FunkUnit's test, is using the QUnit library, QUnit assertions, FunkUnit is going to allow you to script synchronous actions on the DOM. That's a lot of technical terms right there. But what I'm saying is JavaScript, a lot of things are done asynchronously. So if I click, let me go back to this demo. Where did I put it? Here you are. If I click this button, votes change from 9 to 10. Was that synchronous or asynchronous? Well, from the user's perspective, we have no idea. Maybe that up button made just a simple increment on a property on an object. Well, in that case, it's synchronous. It's just find the object, find the property, increment, set the object, or set the property. So it's a synchronous action. But what if clicking this up button made an AJAX request and got set a server method that incremented it and then returned the new value? Maybe that's what happened. We have no idea from the user's perspective if it's synchronous or asynchronous. What FunkUnit's going to do, how FunkUnit gets around this, is we're just going to say, click on the first one and wait until the text is equal to this. So FunkUnit has a, you can think of it as a loop internally. Well, it is a loop internally, where it's just going to wait up to 5 seconds by default until this text is equal to 10. If this text isn't equal to 10 within the first 5 seconds, then this assertion fails. And then it will execute the next assertion. So what these methods are doing are basically pushing actions onto a queue or onto a stack. Well, it's onto a queue. I shouldn't say a stack. It's onto a queue so we can execute these actions asynchronously behind the scenes, if that makes sense. So as an author of these tests, you don't have to think of, well, this button is clicking, this button makes an AJAX request, we have to wait for so long, so we should use a set timeout in my test. You shouldn't be concerned about any of that. I would say...
Sorry, 1 second. Do you want to talk a little bit more about the differences between FunkUnit, Selenium, and Casper.js? Because they all have, I think, slightly different approaches on how they do this. I think to understand what FunkUnit is doing, it's probably important to also say that all of this runs in the browser. FunkUnit is a browser-based library, unlike Selenium, which tries to control your browser from the outside. Casper.js, which runs in Phantom. So it's kind of a different approach for functional testing than the other alternatives do.
No, that's very true. Yeah, FunkUnit. So I guess I can tell you what FunkUnit is today before I give you any history on FunkUnit. David is completely correct. FunkUnit is a really, really small library. It runs inside the browser. It's just a script file that you drop in the browser. Or in this case, I'm loading it via Steele, but you could just have script tag dropped in the browser. And it allows you to select elements on the page and just wait until some value has changed, either the inner HTML or text. That's really all it does. It's a script in the browser that waits until some value of a DOM element equals something else and lets you simulate user actions. When I say simulate user actions, click is always one of my fun examples. I'll typically say to a room, how do you trigger a user click event? How do you actually simulate a click? And you'll get a lot of like dollar button, something like this, dollar button dot click. This will trigger a click event through jQuery. And this is awesome, but this is not a true user click. A user clicking an element is going to trigger the click event. It's also going to trigger the mouse down, mouse up, and input event potentially. So there's many events that can be triggered. So you want a library that accurately simulates user interactions. FunkUnit internally uses something called Syn, which is synthetic JS or synthetic events. And Syn is what gives us the power to simulate those events. So when this method click happens, you'll know that it's triggering mouse down, click, and mouse up, etc. All the events it needs to accurately represent a user clicking. Selenium does something similar, but it's not in the browser. Selenium is running on the operating system level, controlling the browser. So this is how you can macro different things. I believe in Selenium you can actually macro clicking browser interactions itself, I think. Is that correct, David? I can't remember. It's been a long time. Like favoriting or whatever. I'm not entirely sure. But Selenium is outside the browser. Gives you a lot more control, but it's also the syntax I find really, really heavy. I find it more difficult to maintain Selenium tests over a long period of time.
Especially when your browser updates and something changed. And so
yeah. I actually haven't seen a team. I've seen many teams have a large suite of Selenium tests, but in the past decade or so that I've been in UI development, I haven't seen a maintained set of Selenium tests.
Yeah, you're totally right. Basically, they started breaking, and as soon as your tests become brittle, if you didn't change anything, well, that's a sign for if they break and you didn't change anything in that section. It's a sign for brittle tests. And if your tests become brittle because your testing library fails, then people start ignoring them, which basically leads to the testing being useless.
I agree. Casper is actually fairly similar in this approach to FunkUnit, but it's meant to run in Phantom. So it's a little bit higher level, I guess, in terms of where it's run than FunkUnit. FunkUnit is just a JavaScript file that you drop in a page, which means if you can open this page in Phantom, then you can run your tests in Phantom or in whatever you want, any browser you want.
Mobile, those sort of things that are important. A problem we found repeatedly with Phantom is you're not really testing your browser.
Exactly.
Phantom 2.0 made things better, but until that release a month or two ago, the problem also was that you couldn't use sometimes even trivial ES5 features because the JavaScript engine was so old. So it's tricky. Like if you have the choice between testing in a real browser where it's actually going to run and a headless browser, I'd always recommend choosing the real browser.
This is a great segue. It's almost like the next topic we want to talk about is running the tests, and I'm really excited. So let me show you what this is doing really quick. FunkUnit is doing it really quick, and then we're going to get into everything David just said because that's really important. So here, this script is just saying, click on the first. Make sure the first table cell. Or excuse me, the first row, second table cell text is equal to 10. Make sure we're starting out with 10 votes. Then click the first button, and now that first value should be 11. Click the first decrement button, downvote, and it should be 10. So I'm going to adjust this. f.speed is equal to 200 milliseconds, I believe is a good speed. I don't know if that's slow enough. 500 milliseconds. And we should see this slow down. Oh, that's still really fast. 2 seconds. Okay. The page opens up. Oh my god, that's still really fast. I think there's a cache thing going on with speed. But what FunkUnit's doing is it's going through, opening this page in Popup. So
press Command Shift and R, it should reload.
Yeah, I can kill the cache here just by, whoops.
Or turn on DevTools.
There we go. That should do it. There we go. Open the page, wait 2 seconds. It's gonna wait 2 seconds between each interaction, I think. There it goes, clicks the first one. The upvotes, wait 2 seconds.
Pretty slow.
2 seconds was too slow. Should have changed it back to 500 milliseconds. And you can see the downvote clicked, and the votes got asserted, and now finally we got our green assertion over here. So FunkUnit's really, really nice for keeping things isolated. I like this. You'll notice that the application is in a pop-up, which means we're not polluting our application state. Your application is opened in its own pristine state in this new window, and FunkUnit just has a handle to it and is clicking around this window. If you've ever done any pop-up or iframe development in your applications, you know each window has a connection to each other window, and you can reach inside everybody's window. So there you go.
Just make sure your pop-up blocker is disabled.
Yeah, if you're using
which is difficult in automated continuous integration. Are we going to talk about continuous integration today? Maybe a little bit.
A little bit. We're not going to get into how to set up your own CI server, how you run this in continuous integration. Well, I take that back. We're going to tell you how to get started and how to run this with continuous integration, because it kind of goes hand in hand.
So just to mention it here, in the case when you have a fresh browser that might have a pop-up blocker, like Firefox, you have to run it in a frame on the same test page, an iframe.
Yeah. So this brings us to what David was talking about. It's important to run things in a browser versus Phantom. And how do you run this in CI? So we're going to get into that. There's a couple tools. There's a few tools. These are some of the big ones. Testy.js and Karma that are very popular for running the tests, specifically automating the running of the tests. Now, I'm not including things like grunt tasks or gulp tasks. Those are also going to run the tests as well, but they're specific to each library's author. So QUnit has a grunt and gulp task, and so on and so forth.
And only in Phantom.
Exactly.
But only Phantom.js, yeah.
Exactly. These are libraries that were independent from your test frameworks and browsers, intending so that you could test many different scenarios. So Phantom has been really, really convenient over the years. It's easy to run tests from the CLI. But if you have a complex application and your tests pass in Phantom, what does that mean? That just means your application works in Phantom, which is great, but that's probably not the browser you want to support. Phantom, even Phantom 2.0 is an older version of WebKit. Today, Chrome, Opera, and I think it's just Chrome and Opera that run on Blink. Safari runs on WebKit, and Firefox runs on one of the various monkeys. I'm not sure which monkey we're at these days. Well, I should say Firefox runs on Gecko. And the JavaScript engine is one of the monkeys. And IE used to run on Trident, but I have no idea what IE runs on today. But you probably have an application with a matrix of support. I needed to run on IE 11 and 10. I needed to run on latest Chrome. I needed to run on latest Firefox and Safari version X. That's typically what you need to do. So it's nice to have a system to automate that. So let's talk about how we run the tests. So what we use, now you have this awesome FunkUnit page and this awesome QUnit page that you can run tests. But as a developer, I don't really want to open those pages up every time I test. You should, but if it's a large suite, maybe you don't, or maybe we're lazy. So you want a way to run it from the command line so that the developers can run it easier, but also because you can automate this. So if you have any kind of continuous integration, such as Travis or Jenkins, you can tell that server to run this command, which will run the tests. So let me show you how we do it here. And I'm going to do it from the command, like the simplest level. I'm not going to use any grunt tasks yet. But we use Testy. It's one of our beta projects. David is the author of this project. And I'm going to run our QUnit tests. So let's do this. QUnit HTML. And I'm going to run it in Canary. And let's just start there. So what this is saying is I'm going to pass this file, this HTML file, off to the Testy application. And I want it to run this test file in these browsers. So right now I'm going to use Canary. So if I hit enter, it's going to, my hands are off the keyboard at this point. And it's going to pop open Canary. It's going to run the tests and close Canary. It happened really quick, but let me go over to our terminal. And you can see we have our results. This is really, really nice. It's actually passing the correct exit codes. So if the tests failed, we would get a nice big exit code 1 and a warning. Actually, why don't we show that? Let me break our test again. I'm just going to throw an actual broken test in there just so we can see what's going on. If we go back to our terminal here, we had our nice report. Hey, this test failed. It shows what browser I was using, what version, what the operating system was, what the test actually was supposed to be doing. And here's the actual error with the stack trace, which is really, really nice. Testy is built on, the reporting system is built on Mocha, which allows us to take this a step further. I'm going to change the reporter. Stack.
Maybe add another browser too. Make it Canary and Firefox.
Yeah, we can do that. So if I change the reporter, we get our nice green checks instead of dots. I'm going to change this even further. Now this is probably the most valuable reporter, I think, for a CI. Here is the
I think the Nyan cat is the most.
those valuable. That's true. XUnit is really, really powerful, especially if you're using something like Jenkins. So all I did was run the same tests, but it gave me this XML output. This is XUnit formatted. You can see a test suites and test case elements, which is a file format. This is an XML format that Jenkins can consume. So if you're using Jenkins with XUnit, you get a really nice reported like output. You can have like graphs and like which modules fail and how often they fail. So you're able to quickly, if you have something that can consume this report, you can quickly see the brittle parts of your application. I find this really, really powerful. So an easy way to put this into a test file, if you're familiar with Unix, you can just type this into, I'm going to call this test, I'm going to put this in desktop. I'll put a desktop test results.xml. And you're going to see this pop up. Here the browser goes, test is done. And now we have this test results XML file here. And if I open it up, here is our tests. So it has the results. It has whether they passed or failed. If there was stack trace issues, it's all going to show up information here, which is really. Do you
want to go back to the spec reporter and add maybe Firefox?
Yeah, of course. I wanted to show the XUnit stuff.
Oh, okay.
So if you're setting up CI integration, XUnit is huge. Browsers is plural. So we can do stuff like this. I have a feeling like Firefox is slow on my machine, but it looks, oh, that was pretty, oh, it's going to be, yeah, that was faster than I expected. So what this did is, now
I think it's easier to see if you use the spec recorder.
Yeah, it is. Recorder spec. Let's try that one more time. This is doing is it's opening up Canary, closing it, and then opening up Firefox as well. I believe it's just taking a little bit of time. Oh, it was quicker than my eye could catch it. It already opened and closed. So here we have the same test file, and it ran it in Canary. Here's Chrome, and here's the results in that browser. And here's Firefox, and here's the results in that browser. So if you have a scenario or a matrix of support where you want to say, hey, does my library or application work in every browser? This is a really, really powerful tool to do that. Let me see if I can, I'm going to show a breaking test that is only going to break in Firefox. What's the intentional? VM.
What are you going to do?
Adder watch. Ooh. I think that breaks Firefox. Let me double check. Subject. Watch. Watch. Let's see. Did that really let me assign it? There's a property called watch that's specific to Firefox. I just documented the bug. That's the only reason I remember this. That somebody in our community.
Well, let's maybe run it and see if it breaks, but it might not, right?
Yeah, I was trying to intentionally break it only in Firefox so you could see the report. Oh, it did. I think that broke. Yes.
You sound so excited about a test that broke.
I'm really happy. Well, I wanted to show, so here we have an example.
I'm not happy.
No, this is good. This is, it's a browser conflict that I just happen to know about. So we have our tests that work completely fine in Chrome, and this is a great way to test your app. This is actually a really good reason why you should use a tool like this to test in a matrix, because if your tests pass in Phantom, that doesn't mean they're going to pass in Chrome or Firefox or Internet Explorer. That just means they pass in Phantom. So here we have a simple test, and all the tests pass in Chrome. So even if you're using Chrome, a real browser, to run your tests, that still doesn't mean your application is as robust as it could be. So what I did, knowing that the watch is a property, it's like a reserved property in Firefox, I knew our tests were going to pass in Chrome, but sure enough, because we have this testing across the board in Canary and Firefox, our downvote test failed. Here's our stack trace, which is awesome. So we got a nice big, this is actually the error. Yeah, this is all going to break, which is nice. So this is a really good, maybe I made a fix in the code and I ran my test in Chrome and I'm like, thumbs up, ship this into production. But if you have a substantial Firefox base and the dev team was working on Chrome, this would be a big issue. So it's nice to be able to catch or have a tool that can catch these issues long before they happen. I'm really happy that failed. Okay. And I don't know if I have my pop-up blocker turned off in Firefox, but so I'm going to use Canary again, just to show that you can. Here's FunkUnit doing the same exact thing in Canary. You'll see this page open up. There's the pop-up. It clicks around, closes both, and there is our FunkUnit reporting. FunkUnit in this example is just using QUnit's assertions, which Testy is able to read. I know there's a lot of different libraries, but they all work together. FunkUnit does not compete with QUnit or Testy. Those three libraries are completely...
Did we mention that FunkUnit works with Jasmine and Mocha as well?
Oh, yeah. Well, I did, but I didn't. The examples aren't written that way. FunkUnit does have adapters. If you don't like using QUnit, I didn't want to turn it into too much of a FunkUnit thing. But here's funkunit.com. I think this demo is actually broken. I don't want to run it. But you can run, oh, it works in Jasmine. Nice. Let it finish running. Sweet. We do have Jasmine 1.0 and 2.0 adapters. So if you're using FunkUnit 3.1 pre-0, I know that's a pre-release, but it'll eventually be the actual release as soon as we get the documentation cleaned up. We have support for Jasmine 1, Jasmine 2, Mocha, and QUnit. So if you like using any of those underlying libraries, FunkUnit can be stacked on top of it for functional tests, if that makes sense. Yeah, I think that was the majority of what I wanted to talk about. Let's see what we got left. Yeah, that was it.
45 minutes. Good
yeah,
time.
That's good. I didn't know.
So I guess for continuous integration, you already mentioned it. In reality, maybe you can show a Travis YML of one of our projects. Totally. What you do is you just run those. You just add those commands that Alexis showed earlier into your test command, and you will have an automated test suite. So we are running NPM Tests here and tell Travis to load a window manager so that it can start Firefox. And our NPM test script is just running in this case, a grunt task, but you could just run the command that Alexis showed on the command line.
Yeah.
And then you'd have continuous integration. So there's really no reason not to do continuous integration anymore. There's many great services, and especially for open source projects, they're all free.
Totally. Travis is free for open source. So if you just want to get something started with automated testing, I highly recommend it. This is our setup file. This is for CanJS. This is probably the most complex CI managed project we have is CanJS. And this is 12 lines it takes to set it up for us. Typically, it takes way less. You typically don't even need this bottom 6 lines. Yeah. And if you're new to Travis, you don't need line 1. So you can get it done with these 4 lines of code. What this looks like is, if we actually ran Travis, Let me show. There's CanJS. Here's the latest run. You can see the last. Looks like David merged in a pull request, which kicked off. Just merging in the pull request is what kicked this test off. David didn't do anything extra. Travis was able to pick this up automatically, which is nice. And if I open up this individual test run, you can see what this did. So this is our automated script kicking off. You can see each one of these tasks. We're cleaning a directory. We're building some application, which is CanJS in our case. We're creating some test setup files, and then we're running, this is all just setup and build. Here we go. Each one of these dots is an assertion. So we're running a whole lot of tests to make sure.
About 18,000.
Yeah, this one's 19,023, or 20,018 on the second run. So we are running a ton of tests to make sure that this application, this library, is as robust as we can make it. But a developer individually running 40,000 tests combined, this could take 20 minutes or 15 minutes to run all of these tests. That's probably not something a developer is going to waste the time doing, or take the time doing. I shouldn't say waste the time, take the time doing, but something should be doing it. So it's nice to have an automated system. So typically when I write a feature like for CanJS, I will test the module that I'm working in. I'll run all the tests, which could still be hundreds of that module, but I won't test the entire library. I'll make a commit, and once the commit happens, Travis will come along, run the whole tests, and then I can come back and be like, oh, it looks like this breaks in Firefox because of this property, so I'll fix that. So it's a really, really nice security blanket for your application. Sweet. Let me go back to the Hangout here. Let me check, stop presenting. There we go. No questions in the Gator or in the Q&A. Is there anything else you'd like to touch on, Dave, before we?
No, I think we talked about everything. 45 minutes.
Yeah, that's good. Let me see. If you have any questions at all, maybe you're watching this podcast not live and you still have questions, join us in Bitobi/JS-training. This is our Gator chat room. If you're unfamiliar with Gator, it's kind of awesome. It's basically just IRC for GitHub projects. So check it out. We're always in there. I'm myself, Justin, David. There's quite a few core members in the JS training room. Brian, Chris, I see a few people in there. So come out and join us if you have testing questions or questions on anything really. Hang out with us. We like chatting with people. Next week, our podcast will be talking about can map and can list. This is our approach to observable objects and observable arrays. So you can listen to when properties change on each of these types. And I do believe at some point in the future, I don't see how far in the future it is, but I believe we'll be talking about a little bit more about continuous integration in depth. So I think that's it. As always, if you joined us live, thank you for joining us, and we will see you next week.